Hi guys, hope you're doing well. I'm sorry I'm just posting this video and this project a little bit later than normal. I've been really busy, as you can see. This is where my garage used to be, and they are digging all around it. I'm going to be getting a new foundation in the next couple days, so I apologize. I apologize to those of you guys who've been looking to see if I was going to have an assignment. Well, yes I do. This is going to be a fun one. I'm really looking forward to doing it, and I really hope that you guys get to do it. Let's go take a look. Alright, so guys, this is what we're going to do. We're going to do something to this can. I'm not going to tell you what's going to happen because you have to do this yourself, and then you have to write me a little paper on what's happening. I'm going to give you some more information, what's going on. I'm going to try to do this quickly because I have some crazy kids in here. Anyways, you need a regular soda can, empty. You need a bowl of ice water, and you need some type of pan, okay? And you need a stove and parents' permission. You first are going to take the soda can and you're going to put just a little bit of water in there. Just a little bit. You're going to put it on the stove, on the pan, and you're going to turn it up.
Why are you doing that, Dad?
See? This is crazy. This is why I can't do it. Alright. Here's a little hint I'm going to add in here real quick. If you put a little bit of salt into the water, just a little bit. That's all you need. Then just stir it in. What it does, the salt molecules actually displace the water molecules and actually lowers the freezing point to about 28 degrees Fahrenheit, which is why oceans don't usually freeze. And what it's going to do is actually going to make the water a lot cooler, so it'll help the contraction. You'll see. All right. So you turn on your stove to get this pan hot. Should have a little bit of water in there. That's going to heat up the aluminum and probably end up boiling a little bit of water. You should see some steam coming out of there in just a little bit. All right. While that's cooking, let's think about some things. The aluminum can is made of metal. It's a good conductor. So the heat from the frying pan is going to go up and it's going to heat up the can. Now the air that is inside of the can will also heat up, but because the can is open right now, that hot air can escape. But that still means that there's some hot air inside of there. Now what we're going to do is we're going to cool it off very quickly. We're going to flip it upside down and we're going to trap that air in there. Just like if you were to take, like in a pool, and cup the water, go down, that air has nowhere to escape. So if you turn the can upside down, that air will have nowhere to escape and it's going to condense very quickly. Let's see. That scared me. There you have it. Let's take a look at some other videos to show you how this works.
Let's look at this experiment a little closer. Before we heat our can, it's filled with liquid water and gaseous air molecules. Heating our can adds energy to our liquid water. The more energy we give our water molecules, the more excited they get, and the further apart the molecules spread. Once enough energy has been added to our liquid water, it changes state from a liquid to a gas. This gas is called water vapor. As our water vapor fills our can, it presses against the sides of our can, creating an increase in pressure. When we place our hot can upside down in our cold water, all the water vapor molecules that fill our can get really close together and turn into a few drops of liquid water. This liquid takes up a lot less space than a gas. Water in its liquid state doesn't exert nearly as much pressure on the inside of the can as it did in its gaseous state. At this point in our experiment, the outside atmospheric pressure is much higher than the pressure inside the can. In nature, pressures want to be balanced or in equilibrium. This imbalance causes the can to violently collapse, creating a balance between the pressure inside and outside of the can. This violent collapse toward the center of the can is called an implosion.
All right, here's another big hole. That's like 12 feet deep in the ground. It's pretty crazy. All right, so that was pretty fun what we just did. So for one, I want you guys to be safe when you do this. All right, make sure there's an adult around. I know I already explained that, but please, seriously, this is pretty scary. You saw it happens very fast. So what I want you guys to do is you can do this experiment. Please then send me a picture of the crushed can. If you want to just go ahead and crush a can, don't worry about it. Just don't even do the experiment if you feel like you want to cheat on this. This is just for fun. If you could do it, great. If you can't, don't worry about it, okay? Whatever. Just do it if you want. But everybody has to submit a paragraph or a few sentences explaining how this happened. In this video, you just saw an explanation. There's actually another video on this I'm going to post of a class in high school actually imploding a 50-gallon drum. A larger scale of this, but it's the exact same thing. So if you watch these videos or even go on YouTube and see some other videos, you'll get an idea of how this works. I want you to, in your own words, using some big vocabulary words like air pressure or condense or contract, or implode. Those are some good words. Use those words in your explanation. Don't copy and paste anything, please. Just write down a couple sentences explaining to me why the can's crushing. That's it. Again, if you want to do this experiment and feel how fast it happens and the force, it's really awesome. But don't go ahead and just take a can and crush it and say, hey, Mr. DePace, I did this. All right. What I'm really looking for is that paragraph. I know you understand what I mean. Some of you guys who did the magnet with the battery, the electromagnet, remember? You didn't have to do it. It was optional. I didn't grade it, but for those of you guys who sent me that work, I really appreciate it, and I love seeing the videos. And some of you guys had some magnets that were super powerful. That's awesome. So please keep up the good work. I really do miss you guys. I don't know that I'll see you again at all till next year, but I'm still gonna be sending these videos. Email me anytime, okay? For those of you who are emailing me, you know I'm getting right back to you. So any questions at all, even if you guys just want to just talk or say hi or something, I'm here. All right. Be in touch. All right. Bye.